Okay, hello everybody. Okay, 6:01, so we can go live at this point. I hope everybody can hear me and see me. So first of all, thank you for joining this session. It is a pleasure that we're able to come together to host this hands-on webinar. My name is Dorcas Osikorodia. Some of you might know me, some might not. I'm the growth and digital marketer with BNet Learning. And BNet Learning, as you know, it's a professional development platform for professionals. Basically, we are looking to do certifications that are global. You have the business analysis certification, we have the data analysis certification. We also offer project management certification and also Scrum Masters and Scrum Product Owner. So if you are looking to do a certification exam in any of those four courses I've mentioned, then we are your best bet to succeed because I mean, one of the good news we have achieved this year is we've achieved 100% pass rate, which is very, very awesome. Speak of last year, we had 96%, but this year we're at 100%, which is great. So yeah, we can say we got you covered. Okay, so this webinar, as we know, is data analysis using R, that's R programming. Olumide Oyalola will be the one taking us through the session. It's going to be a lot more practical compared to our other sessions. So if you want to get your pens, get your paper, be ready to jot things down. All right, and let's make this session as engaging as possible. If you can share your name or where you're joining us from, you can use the chat box to drop that information. It'll be nice to see you guys or know you guys where you're joining from and who are talking to. Okay, so in the chat box, you can just drop that. If you have any questions in the session, please also note that you can drop that information in the chat box. Okay, I see some people. I see Michael Uzo from Abuja. It's nice to meet you. I see Uzochukwu from Lagos, Nigeria. I see Dami from Winnipeg, Canada. It's nice to meet every one of you. I raise it from Enugu. Wow, it's nice to meet you all. Okay, great. So we should be familiar with the chat box. If you have any questions, please feel free to drop it there. We'll get to it. General rules and regulations, sorry. Like I said, drop your questions in the chat box. During the sessions, we will have like polls and quizzes just to try to keep you guys engaged. So you can check when the poll is live, you would see a notification on your screen. Try to attempt the questions just to ensure you're following. And if you have any questions that are not answered, let us know. Okay, so I think that is it. But first, I have a question for everybody on this call at this point, right? So we are talking about data analysis. And there's this popular myth around, oh, is there a difference between data analysis and data analytics? So before Olumide gets to answer that question, it'd be nice to see what everyone on this call thinks. Is there a difference between data analysis and data analytics? So let's have your opinion. What do you think? Is there a difference? If it's a yes, if you can type in your answer as to why you think it is a yes, maybe let us know in the comment section. Okay, so at this point, still try to attempt the question though. At this point, Olumide, I'll pass it on to you. Olumide is a data analyst and has been doing this work for more than a decade right now. So you can trust that you're in good hands. He's going to take us through the session and show us what we need to learn. So Olumide, you have the floor.
Mic tests.
Yeah,
thank you, Dorcas, and welcome all to this wonderful webinar. So we're firing on from this moment. I guess I have, okay, good. I have access to share my screen. So I'll do that in a minute. Okay, let me move the control. Sorry. Okay, can you see my screen? Yes?
Yes, we can.
All right, awesome. So we are welcome to this webinar, Data Analytics with R. As Doka said earlier, my name is Olumide Oyalola. And for today, we'll be taking a look at a form of analytics. And thereafter, we'll see the engine, the analytic engine, which is R in this case, that actually generated the analysis. Okay, so introduction of BNet has been taken already by Dorcas. So let's get started operationally. Okay, the first thing I want to understand is data analytics is more of a workflow. So it is scientific. You can say it is scientific in the way we actually approach it, looking at the technical aspects, right? The technical aspect simply implies there is already a business question or a business concern, and effort has been made in distilling the business question into an analysis question, and data sets has been identified that will be useful for this endeavor. And the appropriate data sets are also in a location. It could be a CRM, that's your customer relationship management software. It could be your ERP system, ERP enterprise resource planning, or it could even be just a normal SQL database or an Excel file that you've been keeping for some time. So that is the data set that has been identified. However, in analytics, the workflow we have on the screen that we can all see on the screen briefly captures everything that happens, right? So the first thing is you try to import. So you're importing because the data is actually in another location, say an Excel document or in your SQL database, and you're importing it into the R engine, right? So R is a statistical software that's gaining relevance in mainstream analytics. So you import, then you tidy. So what does tidy implies? It's similar to what you might want to think, like putting the data in a neat form and also trying to clean the data set. So what tidy actually implies in this case, it's a word that is actually used in analytics space. And you're going to see in the subsequent slide what tidy actually entails. So for that, I'll leave it until we get to that slide. Then you transform. So transform is a form of cleaning because majorly the data set might not be in the right form that you wanted it. For instance, you'll be familiar with male. Let's say you have a data set that has gender and you have male and female, whereas M is coded for male and F is coded for female. But however, for the case of your analysis, you want to find a way to spell out the gender. So instead of M and F, you want to have male and female. So that is a form of transform. Or it could be that you have date of births of individuals in your data set. And from date of birth, you want to generate their current birthday in years. Then from that, you can quickly transform the date of birth using a formula to generate the respective age for the individuals. Now, all you're doing there is just basically to transform. That's an example of transformation that can be carried out. And thereafter, you visualize. So why do we visualize? Graphical view of data sets try to help to see some patterns and some intricacies in the data set. For instance, you might be interested in the distribution. You might be interested in what data really looks like. Are there missing values? You might be interested in what's the distribution of the age or the count of number of male and female that you have in data set. So what visualization help to do is, even before you endeavor to go into the deep analysis, visualizing your data set actually helps to drive home some basic points and also to ask some questions that could then be later be taken into the analytics workflow. Then thereafter, you probably have a model. So modeling is also a key part of analytics workflow. And this is actually where you talk about some machine learning algorithm, all the buzzwords in the machine learning space. And after that, you might still need to transform the data sets. So transform, visualize, and model, it's more like a loop, because at every point in time, after the visualization and model, there might be a need to transform the data set again, maybe to generate some other features or variables, as the case may be. Thereafter, after all the action in the loop has been taken care of, then you communicate, right? So all you are doing in this gray area, you can see my cursor, all you're doing in this gray area is to understand the data, understand and make use of the data. However, the output of this is meant to be communicated. So earlier on, Dorcas asked a question, the difference between analysis and analytics. Now, all what you do in this gray area accumulates into what you call analysis, right? You've analyzed the data sets. Now, until you communicate insights, if at all there are any, you've not done analytics, right? So you've plotted a chart, and the chart shows male are more than female in terms of the bar chart that you have. What does this actually imply? In your business space, does it mean that you have potential male customers, or you have potentially male detractors, to understand, in case you're talking about net promoter scorecards in that sense. So until you communicate, you've not carried out analytics. You've only successfully completed your data analysis. All right, so let's look at tidy. Tidy is one essential part, and understanding of tidy in terms of definition and attributes will actually help to understand a form in which a data set might be, and to assess if the form is good enough for analysis to proceed, or will need to do a form of data cleaning or data wrangling. So first thing first, for a data set to be tidy, it implies that each variable must have its own column. What this implies is that you have an Excel file, the column that are delimited by, or that are named by alphabet, they are meant to house a variable. What's the variable? A variable is just a quantity that changes per case or per individual. So let's say, for instance, you're taking in the score of students, maybe for a particular exam, right? The score of a particular course makes a variable. The score of student for another course makes another variable. So these are meant to be in a separate column. So per course in a column. Another one is that each observation must have its own row. So a row is meant to be for a case of an observation. However, the intersection between a row and a variable gives a cell. And this is also applicable in Excel, and the cell is meant to handle a value. Now, there are peculiar cases in which you have some of the column names are not names of variables, but are values of a variable. So we're going to see this happen out as we go on. I'm going to show a sample of what it is when data set is not tidy and what we can actually do to actually make it tidy. All right. Taking off from there, we talk about the types of data analytics, and I'll also try to pinpoint the form of analytics that we're going to look into in this webinar. So the first part is descriptive analytics, and what that implies is that you're summarizing events that have happened in time past up to the current period. For instance, you want to see you want to see the forex exchange, naira to dollar from 1980 to date, right? All you're doing in that case is just to summarize, to either by aggregating or by visually looking into it, by plotting it on a graph and the like. So when all you do is just to look at what has happened in time past and to summarize what has happened, then you've successfully carried out a descriptive analytics. However, if you then take a further question to say that, oh, why has this happened or what led to this? For instance, the prominent question in the mind of every Nigerian is, why is there a continuous rise in the exchange of naira to dollar, right? Or why is there a continuous rise in the price of staple foods, items? You go to the market every week, and most likely the same item you bought at X naira is not the same a week after. It must actually jump to another value, which is not the same as the amount you paid earlier. So when you have this type of question, asking question why, what happened, then you're most likely doing diagnostic. And what diagnostics tend to do is, after taking into cognizance what has happened in time past, asking a question, what led to this, then it's a form of diagnostic. However, if you want to move on from there, then you talk about predictive analytics. And what the predictive analytics tend to answer is looking at what has happened in time past, they will want to predict or want to forecast what is likely to happen in the future. So looking at the fact that the price of the exchange of naira to dollar has been on a consistent increase in the past 1 month, then it could be tenable to say that the next few weeks we are still going to experience a dip in the value of naira as compared to dollar, right? So that is predictive analytics, and there are a lot of machine learning algorithms that are applicable in getting this done. Moving on from there, then we have prescriptive analytics. So prescriptive, as the name implies, is somewhat like prescribing. So you're prescribing the best alternative whenever you're faced with options, right? You have a concern and you have a particular analytics, or you have a particular problem, and there are 3 probable solutions to that particular problem. Then the best of the best of the best of the 3 solution could then be taken. So when you are faced with this type of decision making, then what you're doing is prescriptive analytics. For instance, you are into a production of a particular commodity, and you have the option to either produce a particular form of that commodity or another form of the same commodity. Say, let's pick Coca-Cola as an example. So Coca-Cola has some basic raw material that are required in making Coca-Cola and Fanta, right? And at every point in time, they are faced with the decision either to proceed with producing an X amount of Coke or an X amount or X quantity of Fanta, right? Now, they need to look into what are the probable profits that to come in from the sale of a Coca-Cola vis-a-vis the sale of Fanta, and what are the requirements in terms of raw materials that will be required in manufacturing a bottle of Coke versus a bottle of Fanta. So when you have this kind of decision making, then what you're doing is prescriptive analytics, and you have optimization, a whole lot of research, operational research methodologies being applicable in this form of analytics. All right. trying to move on. Okay, so moving on from that, I mentioned earlier on of machine learning. So we have classical machine learning, and here we see that basically machine learning it's further divided into two, which could be supervised or unsupervised. And for supervised, we have classification and regression. So first, what does supervised implies? What does unsupervised implies? You must have probably been hearing the supervised machine learning model or unsupervised machine learning model. So supervised is when your question or your analytic journey actually have a variable of interest that you are interested in predicting, or you are interested in classifying or in predicting. Let me just use the word predicting, right? Say for instance, we've seen the value of Naira to dollar over time, let's say from 1980 to date, and we want to use the information available to predict what could be the probable value of Naira to dollar in the next 7 days, right? You'll see that in this sense, we have a variable of interest that we are forecasting or we are predicting, and that is the exchange rate. And in that scenario, we are interested in a supervised machine learning. On the other hand, unsupervised is when there is no variable of interest, right? There is no response variable. So supervised can still further be divided into classification and regression. And this applies to, for regression, it is when the response variable, that is the variable of interest, is numeric, is number-based. And we talk about Naira to dollar exchange rates. You can see that this is actually numeric. On the other hand, classification is when you have non-numeric response variable. Say, for instance, you have data sets on COVID-19 cases, right? And you also have respectable variable that shows if a particular patient that contracted COVID-19 either survived or died after even contracting COVID-19, right? So if the analytic journey is to forecast or to predict for every individual that contract COVID-19, the probability of the person either surviving or the person recovering or probably dying, then in that scenario, we are actually classifying, because we are not talking about numeric quantity any longer. We are talking about non-numeric. We are classifying objects based on some basic attributes. Then we have the unsupervised, which include clustering, association, and dimension reduction. So these are also often used in the analytics workspace. Okay, and there are a whole lot of algorithms that are applicable to classification problem, and they are also applicable to regression problem. All right, so a wise man once said that just because you have a bag of hammers does not make every problem a nail. So what that implies in our own case is that just because you have an analysis problem does not make all the machine learning algorithm that you are familiar with or that you have heard of to be applicable, right? So questions are the answers. This is actually a quote from one of Zig Ziglar's books, which is said question and the answer. I think that's a book on Ziglar on selling. Questions are the answers. What this implies is that it is the question that you have at hand that will determine the tools and techniques that you use to address a problem. And this is the major difference between pragmatic data analysis and non-pragmatic data analysis. By pragmatic, I mean data analysts that understand the basic fundamentals of data analytics, that understand basic statistics, that understand what a particular tool is and what is the best use case for a particular tool or a particular technique. And this is actually one of the things that you stand to gain from this particular webinar. And also, if you'll be taking a next step by coming for our next bootcamp that's coming up later in October. All right, so moving away from that, the goals of this presentation is basically to walk us through an interesting topic, an interesting problem. And because of the diverse audience that we have, we will be looking at descriptive analytics. And the essence of that is because that at the end of the day, we will all have gained something, right? So that is one key goal of this presentation. All right, so in terms of assumption behind this webinar, it's that number one, you understand my language, which is English language, and secondly, you can actually work around computer. So if you can do this, if you actually understand these two, then in that case, you can actually follow through with this webinar. All right, so moving on, food security. So food security, it's one key aspect of every nation, every population, even globally. And is one of the key arm of WFP, that's the World Food Program. That's the arm of United Nations that actually see to address food issue in countries. So you have their operation in some countries, like for instance, in Nigeria, you have the operation in the northeastern part of the country in particular. Now, in the year 2016, I was on a project, a key project from the federal government of Nigeria, and that is actually addressing food production in rice and wheat. And so the reason why they picked those two food items, I don't know, but I guess it's because for rice in particular, maybe because of the fact that it's one of our basic staple food in the country. And thereafter, after this analytic journey, we started tracking the prices of basic food items, about 20 of them, over 20 of them, for the federal government of Nigeria. And the data is collected by NBS. So NBS started the data collection January 2017, and they started collecting the prices of basic food items, over 20 of them, across the states, for each of the states, and across the nation. Now, this essential part of this is because if the prices of food are getting higher unnecessarily, then there is actually an issue. It simply means that larger part of the population might not be able to afford it, right? Or if there is money, people have the cash to procure the food that they need. However, the food is not available, then that is also another growing concern. So this is actually what food security tries to achieve. And the problem of food security is actually food insecurity. And this is actually where foods are not affordable to buy, right? Or on the other hand, they are not even available in the market. Okay, so of all the food items that are being tracked, I chose yam for this analysis. And the essence of that is because yam is one of the basic food items that we don't, as a country, Nigeria, we don't actually import. So we even tend to have excess production of yam that we even take some parts as exports, and even some other ones actually gets spoiled because of poor storage facilities made available. So for this particular journey, we will be looking at prices of yam across the country. Okay, so here we have the map of the country, and you have a color scale, blue in particular. So from light blue to more like a navy blue or a very deep blue. And what that implies is that a state with a light shade of blue depicts the fact that the value of yam in that state, it's a bit low. The price of yam in that state is a bit low as compared to a state with a deep blue color that depicts the fact that the price of yam in that state is a bit higher. Now, I said earlier that the data journey started from 2017. They've been collecting data points from 2017, and they collect it on a monthly basis, and for each of the states, right? So the last data point that I got on MBS website was July 2021, and that is because there's always like about a month lag before a new data set is made available. So by now or by next week, that of August should be made available, because they have to collect it across the nation, do some basic cleaning, and put it in appropriate form and manner, then upload on their website for people to start using, or for analysts to pick up, or for those that actually are interested in taking some decision around that, or that want to use it for one reason or the other to pick up. Right. So look at 18, we're taking the median price of yam. I said earlier that we have the price of yam over time from 2017 to date. And for each of the states, what we have here is an aggregate value which is the median price that stands as a representation of the value of yam in that particular state. The question is, what is median? So median is a measure of central tendency. We must maybe familiar with this from high school. And another class of measure of central tendency is mean and mode. So the question is, why do we have median as against mean or mode? And the answer to that is, if you're familiar with scientific publication, either in the health space or in the economic space, you'll realize that in most cases, they often use median as against mean or mode. And that is because median is not affected by an outlier. An outlier is a value that differs significantly from every other values. So whereas your mean, right, will be affected by an outlier, right? For instance, let's say that we have a set of value, 5, 10, 15, 20. And by chance, instead of imputing 5 in your Excel notebook, you type 50. So you have 50, 10, 15, 20. If you're to compute mean based on this, your mean will be inflated by that particular value, 50. However, if you're to compute median, median would have taken care of extreme values, right? So you have values too far to the right and values too far to the left. However, the middle portion of the series is what median is interested in. And this attribute actually makes it more robust than mean and mode. So that is the reason why we chose mean. So you can see at a glance what the price of yam looks like across the states over time. And in this other visualization, you can see a more like a time series, right? A time series in the sense that you have a particular data point over time. The time unit is actually in months. You can see the months and the value of yam. So this is from January 2017 to January 2021. So the question I want to ask, or that I want us to think of, is there has been this assumption that things are getting expensive. And from these snapshots, you can see this particular point, this dotted area, that captures from January 2021 till date. And you can see that in that gray area, the values there are a bit rising, right? Not even a bit rising, they are rising significantly. What that simply implies is that there is a rising trend in the price of yam across the nation. There is a rising trend in the price of yam across the nation. Okay, so now let's see what happens in different zones, right? Nigeria is a peculiar country that you can't talk about Nigeria without going geopolitical zone, either politics or otherwise. So let's see what happens in the northern part of the country and the southern part of the country. So we still have here more like a time series, our series over time. And you can see that of all the 3 zones that makes up the northern part of the country, the northwest, which is actually color green, I guess I'm correct, yeah, color green, is a bit rising, whereas that of north central and northeast are a bit declining. So that means there is a probable decline in the price of yam in the northeast and the north central. I know, for instance, north central, you have states that are very strong in farming, especially Benue State. So that might be contributing to the reason why there is actually a decline in the price of yam in that particular region as against northwest. Now, you can see that basically we've started answering some basic questions. So why is north central a bit lower as compared to northwest, which is a bit higher in terms of the series, right? Then let's move on from there and see what happened in the southern zone. Southern zone is southwest, south, and southeast. You can see that all the southern region are actually rising. There is a rising trend in the price of yam in all of these states, in the state that actually makes up this region. So let's take the analysis by region and look at states that makes up each of the 6 regions. So we start with North Central. You can see at a brief glance what the price of yam is in North Central by the minimum, the maximum, and the average. right? So we can actually see that, and we can see in terms of series what the price of yam is for each of the states that makes up North Central. So you can see that apart from Abuja in North Central, every other state in North Central actually have a decline in yam in terms of price. So the pricing of yam in North Central decline except for Abuja. So let's look at Northeast. Northeast, we have Adamawa, Bauchi, Borno, Gombe, Taraba, and Yobe. All of these states seems to experience a decline. Yeah, I've seen here. So if you are to plot the trend of this particular series, we will have a decreasing trend, so this is Northwest. Northwest comprise Jigawa, Kaduna, Kano, Katsina, Kebbi, Sokoto, and Zamfara. Don't mind me if you're not familiar with this state. These are the states that actually makes the northwestern zone of Nigeria. And you can see that almost all the states, yeah, all of them actually have a rising trend. If you're to generate the trend line here, is going to be an increasing one. It's going to be an increasing one. So the slope of the trend is going to be very, very positive, going by what we have here. So looking at Southeast comprise Abia, Anambra, Ebonyi, Imo, and Enugu, and all of the states also have a rising trend. So there is actually an increase in the price of yam in each of these states over time, especially for 2021. Then for South, you can see the snapshots of what the value is over time. Then we can see for each of the states. The same thing applies in South. The only good part is that there seems to be a decline at the last month, which is July of 2021 in Cross River. However, for every other state, they are currently on the increase. Even for Cross River, if you're to plot the trend line from this point to this point, is going to be an increasing trend. So over time, the price of yam has actually increased. And lastly, Southwestern Zone. So Southwestern Zone comprise Ekiti, Lagos, Ogun, Ondo, Osun, and Oyo. And in each of these states, there has been an increase over time in the price of yam, even despite the fact that there are a lot of farming activity going on here, but there is still a rising trend of the price of yam. All right, so that's about the descriptive analytics. So the next step that you might want to ask, or more like a question you might want to answer, is after all that we've seen, after all that has happened in each of the states over time, what could be the probable price of yam in the next 12 months, right? Or your own question might want to be, what might be responsible for the rising trend or the rising the rise in the price of yam? And part of the answer to that question could be maybe trying to get some other data points or some other data sets that could actually help to answer that question. For instance, how is the farming activity in those regions? Are there crises that actually make people not to go to farm? Other question could be to what level, what is the government intervention in assisting farmers, right? Another question might want to be what is the conversion rate in terms of what it is farmed, what is harvested, and what is available in the market? Because at every point of this, there are always loss. So farmer, you planted like 10 hectares of land, and you are only able to harvest like maybe about 5 hectares of land of the 10 because there are issues, right? There are security issues, there are intruders coming to the farm. And even of the 5 hectares that you're able to get out of the farm, only proportion of that 5,000 could make it to the market because of poor storage facility. And guess what? The farmer that farmed 10 hectares of land and only have about 2 hectares of land to take to the market is going to find a way to make up for the loss, right? And at the end of the day, it might actually add some value to that. So these are many questions that you might want to have as per your next step. So briefly, we've actually taken a look at descriptive analytics, which is just basically describing what has happened over time. And as per your next step, it could be to see what could have led to this, or what could be the price of this particular staple food in the next 12 months. And the overall next step could also be that, oh, I want to know more about this. I want to see how this is generated. I want to see the tools and techniques that were applied in actually generating this. Yes, we are going to have a quick turnover of the screen to showing the analytic engine that generated this. And on the other hand, to see more of this and more of this form of analytics, and to actually go through the respectable steps in getting this done and many more. We'll be inviting you for our bootcamp, which of course we'll have a few moments to talk about after my section. So I'll be changing my screen from here to the engine that generated the analytics. So now you can see the black box. Yeah, it's not looking interesting. But funny enough, this is the screen that generated the deck that I just presented. So I generated the deck using this tool called HAL. Now, what you're seeing currently is RStudio. So RStudio is the platform in which I'm running R. So you can actually call it in technology space, we call it an IDE. An IDE is integrated development environment. And what that implies is that it actually makes your work on R to be much more easier. Yeah, that is actually the simple explanation I can give to an IDE, what an IDE does. So, and this is called RStudio. Now, let's just take a quick moment to go back in memory or in retrospect to what I said as regards tidy data sets. I mentioned 3 attributes of tidy data set. I said each variable must have a column, each observation must be on a row, and each value must be in a cell, right? Now, this is the data sets that I downloaded from MBS. This is a full data set, and you can see each of the states on the, you can see that each state actually have a sheet in the Excel workbook, right? If you notice, you'll realize that the column actually have date information, right? So what happened is that we have the item label, which is the food item that are being collected, that are being tracked on a particular column. And then we have the time point at which the data set is being collected, making specific columns, right? Now, bringing back our understanding of tidy data sets, all of this information on the column, all this data information are meant to be a value of a variable, because what they actually answers to, they answer to the time point at which data set is collected, and they are meant to be a value in a variable, not a variable themselves. So this data set is not currently tidy. It's not tidy. It's not tidy because basically this information on the column are meant to be a value in a variable. And that is one of the reasons why I made mention of tidy, because in most cases, the data set that you might probably have is not going to be in appropriate form and manner in which you want to, in the manner that actually it's useful. For instance, if you're to take these data sets and you want to visualize it, or you want to use it with either Tableau or whatever BI tool you are familiar with, be it Power BI, and you want to generate similar visualization that I described, it will be impossible because the data set is not in the appropriate manner, it's not in appropriate form in which you can actually get to that. So let me quickly do a walkthrough of what we have here. Earlier on in the workflow, I said everything starts with importing, and here is actually the line of code that actually imported the Excel file into R, the same way you load your Excel file to Power BI or to Tableau as your BI tool, the same way you also import the Excel document into R. It could be a CSV file, it could be an Excel document, it could even be a SQL database that you want to import from. And all of the action that happens from here downward are part of what I explained under tidy, right? Are part of what I explained under tidy, ensuring that each column is only a variable. Every column is a variable, every row is an observation, and the intersection of this actually results into a value. So that is what we have there. And moving on, yes, there are a bit of transformation here. The transformation includes trying to ensure that the date information is actually appropriate, so that at the end of the day, if you are plotting on a line, if you are plotting a line chart, we can actually see it in a series form. And even at the end of the day, I also try to get month and year components of the date information. I said earlier on that you might have date of birth in your data set, and you might want to get the appropriate age of the individual that you have the date of birth. What you're doing is that you're trying to transform the data from just mere date of birth to the respectable age. And in that sense, you're doing data transformation. And that is part of what we have here. And as part of also data wrangling activity that I carried out, is actually getting to merge two data sets. Now, the data set from MBS does not include geopolitical zone. We only have them by states. However, I still want to be able to show what we have by geopolitical zone. So what I did was that I created another data set in Excel that contains states, each of the states, and their geopolitical zone, and merge these two files together. So if you're familiar with Excel, this is similar to more like doing a VLOOKUP to take in a particular column in a particular sheet and merge it with another data file. And if you're familiar with SQL, your SQL, this is actually joining. And in particular, I did a left join. And moving on, then here we started, okay, here we have the data set for YAM. Because I said earlier on that we have a whole lot of food items, but we are only interested in YAM. So I filter out YAM. This is similar to what you do in Excel, where you try to filter a particular column and you pick the only particular value that you are interested in the column. And that actually limits the record that I've actually returned. And that is what I did as well here. And thereafter, we started data visualization. So all the forms, all the versions that were presented earlier on in the deck actually came from this black box, right? So these are many more are what you stand to gain, you stand to learn if you come for the bootcamp. And as I said earlier on, the assumption is very basic. You understand English as basic mode of communication, and you can always work your way around your computer system. And as part of what you stand to gain, yes, we start from basic statistics. We won't take assumption on that, even though you might have good understanding of statistics, but we still have to take some basic statistics. And then we go on to R, introducing you to R, having a good understanding of R and how you can carry out a descriptive analytics endeavor or descriptive analysis tasks with insights. That is that. So that is that from my end. I'll stop sharing my screen so that Dorcas can take over the section. Thank you.
Great, thanks a lot, Olumide, for this session. I believe we have learned a lot in this session. So I'll just go straight to the Q&A. Mike Betts, if I got the name right. Olumide, so he's asking, apart from NBS, what other open sources of data are available out there for practice?
Okay, a whole lot of data points are actually available. Yes, NBS is actually what I used here. You can use Index Mundi. Index Moody also have a lot of data points, they track a lot of statistics. You can use trading economics. Trading economics is also another good data repository where you can get varying data points on different parts of they track a lot of things in as regards economy of the country. You can get things that regards to Nigeria, pertain to Nigeria rather, and also other countries. And just to add to it, you can also get your data from Aboki effects. Yeah, you can get this data from Aboki effects. All right, that's just on a lighter note, though.
Yeah, no problem. So I see Fatima is asking, please, which data app is this? R Studio. I think it is.
Okay, yes. So the black box we saw earlier is R Studio, but the main engine is R. So there are two separate things. There is R Studio, there is R. So as I explained earlier, R Studio is the R Studio is the IDE, or I call it the platform where you interface with R. You can actually interface with R directly, but the concern is that it's not that user-friendly. Let me just put that as a caveat. However, you still have some users that prefer to use R directly, but many users, including myself, would like to use R Studio to interact with R. So R Studio is just an IDE, whereas R is the main engine.
Okay, perfect. So I see Damilola is asking, thank you for the presentation, but how do we learn the R Studio? I think this is the point where you say you sign up for the bootcamp. We'll have the bootcamp coming up in October. So you will learn, like, it's a bit more practical in the sense of bootcamp. Like, we're going to do more hands-on training. You and Olumide will be doing a lot of more hands-on training in the bootcamp. So if you're interested, definitely you should join the bootcamp. Mike Pett says, thank you for the session. Great one. The bootcamp would be terrific. Yeah, definitely is going to be. So Ismail Fatai says, please, how can we download our studio?
So R Studio, you can get it from rstudio.org. I'm trying to check to show that I'm actually correct. Yeah, so there are actually paid version for R Studio, but you can always get the R Studio desktop, which is actually open source, and that is actually what I'm using. It's free of charge and is available for Windows, Mac, and different versions of for different binaries of Linux. Either you're using Ubuntu or you are using CentOS or whatever. Yeah, you have access to it. So you can download R Studio from that site, and you can also get R. Just if you Google download R, you can get that.
Okay. I see Aya's asking, is it advisable to use the cloud version of R Studio?
Yes, you can use the cloud version of R Studio, especially if you are not, you don't have your own personal PC. But using Cloud Studio also come with a caveat that you also need access to internet, right? So if you have these two luxuries, if you meet these two concerns, then you can do that. However, the concern I actually have with the R Studio cloud version, especially for the open source part, is that it comes with basic limitation, and limitation is that you have a RAM capacity that is made available for your use. So maybe about 1 gig RAM or 2 gig RAM space that is available for use. And in case you're working with a large data set, or you have a lot that you're doing that is taking your RAM space, this is going to slow down your activity. But for practical use, for practical cases, you can make use of it. And if you have your own personal PC, I think you can also download and use the desktop version. So you have those two at your disposal.
Okay, perfect. So I see a couple of people asking about the bootcamp. So definitely, if you used your email to register for this session, you will get an email. We'll send you more details about the bootcamp to you in this week, like the week to come. So look out for that. I'll take one last question. Temitope says, what is the similarity between RStudio and SQL or Python analytical tools? I think that'll be the last question for today. So let me over to you.
I'm trying to see how best to address this. Okay, first, RStudio is a tool, right? Being a tool, you can't compare it with SQL directly, right? SQL is a language that your SQL database actually understands. That is the language that you use to interact with the SQL database. However, you can write your SQL in RStudio. So RStudio actually give room for other languages. Like you can do JavaScript, you can write JavaScript in RStudio, you can write CSS in RStudio, you can write your Python in RStudio, you can write your SQL in RStudio. The same way you can use VS Code or Visual Studio Code as an IDE. You can also use RStudio. But basically, RStudio was built with R in mind, right? Now, Python analytics tools. Well, I don't understand clearly what this means, but what I'm going to say is that Python is also is a programming language, and it's used for general purpose programming and also used for analytics, right? And you have a whole lot of libraries or modules or packages that actually make this possible. So that's about that. So in terms of comparison, I'm not sure they are basically comparable, right? They have their different functionality, which actually differs essentially. So how do we connect our out to SQL? Basically, I would say that these and many more will be taken in the webinar. I actually have a whole lot of packages that actually make working with R with other tools and technology very, very simple and easy to go with. For instance, at the point in my career, I've had to connect to a Postgres database. I've had to connect to a SQL database. I've had to connect to what to that data say? Either I think MySQL as well, to actually to work in R. And I've had to even connect with Access database as the case may be. Difference between R programming, Tableau, and Power BI, I think. So Tableau and Power BI are basically for business intelligence. You want to do descriptive analytics. Yes, you're cool with Tableau, you're cool with Power BI. And one other thing is that they are majorly drag and drop. However, R programming is not entirely drag and drop, even though there are some packages that actually make drag and drop possible, but it's such that you need to write your code basically. So all the visualization that we saw earlier on, you need to generate them with some basic code. The good thing about it is that you are not limited to what is available off on the shelf. Do you understand? You can actually generate your own contents, and that's a good part of going the programming route.
Okay, perfect. So in the course of the week, we'll also share, you definitely get an email from us, right? So if you'll be joining the session, we look forward to having you. And if you have more questions, then you can reply the email. We'll drop a form where you can fill in your questions, and we'll try to get to them in the course of the week. But we promise we're going to give one lucky person a free, fully BNet Learning funded data analysis fundamental class, and we intend to do that right now. So if you register, definitely your name is on this wheel, right? So we are going to spin the wheel, and if you're in this section, just drop a yes or yay in the comment section. So this is me. We spin the wheel now. Who is our winner? Okay, is Temitayo Adebisi Adekule in this session? If you are here, please say yeah in the comment section. Let's hear from you. Going. Okay, Timitaya is in here, so we'll take a second row. Let's see. Oh, sorry, it's my Fata. Is that you? Okay, we have Edwin insert. Sorry, just to confirm, it's my Fata. Okay, sorry, it's my Fata. You say yeah. I don't know if that is you. We'll take one more spin though. Let's just do one last one. For our lucky winner. One last spin before we end the session. Okay, so we have Rebecca Torres. Um, okay, so with this, that will be the end of the session. If you'd be interested in the bootcamp, this is the bootcamp details will be coming up October 16th. Sorry, let me just change my screen so you can see the date of the class. For more information, the class will start October 16th to October 24th, right? So like we said earlier on, if you have more questions and then more details about the course and the bootcamp is going to be shared to your email in this week to come. So at least we'll have enough time for you to prepare and get yourself ready for the bootcamp. So with this, we'd like to say thank you to everybody for joining the session. For the people that Ismail will reach out to you in the course of the week too, just to confirm. And then, I mean, if you're the winner, congratulations. Whoop, whoop. Okay, so that is it. Thanks to everybody. Let's have a wonderful evening or morning or afternoon, wherever you're joining me from all over the world. Thanks to our speaker, Olumide, for the session. Let's have a great day. Thank you and have a nice day.
Thank you.
All right then.